Hello everyone, in this video we are going to talk about some questions based on previous two classes. Okay, in previous two classes we have learned what are the properties of charges and how to transfer the charges, right? How to conduction, induction, how to do that, right? So there are various methods of transferring charges. Let's do the questions. First question is find how many number of electrons make up -1 Coulomb charge. Okay, how many electrons will make up -1 Coulomb charge? This is the question. Let's see how we can do it. We know Q is equal to N times E, right? Q is equal to N times E. N is an integer and E is a charge on one electron. So Q is given to as -1 Coulomb, that is the total amount of charge, and N is the number of electrons, and this is going to be -1.6 into 10 to the power -19 Coulomb, right? So we can cancel out this Coulomb, this minus signs here, and we will get 1 upon 1.6 into 10 to the power -19 as number of electrons, right? So let me simplify this. N is equal to 10 to the power 19. Now this 10 to the power 19 I will write as 10 into 10 to the power 18 divided by 1.6, right? Okay, so I can divide by 2, this is 5 and this is 0.8. Then what I am going to do, I am going to multiply by 5, so this is going to be 25 and this is going to be 4 into 10 to the power 18. Again I will multiply numerator and denominator by 25. Now this is 100 into 10 to the power 18. So this is going to be 6.25 into 10 to the power 18. So this many electrons will make up -1 Coulomb charge. Now people will say, okay, this is a fractional electron, right? 6.25. How it is like that? See, it is not a fractional, okay? It is actually, if you multiply by 10 to the power 18, it is going to get you an integer, right? Okay, let's look at the next question. Is what will be the charge on 10 gram plate of copper if one electron is removed from each atom of copper itself? So let's look at this question. We have a 10 gram of copper, right? Now 10 gram of copper means how many atoms are there? Because in each atom, from each atom, one electron is removed. So if I want to find out that, how will I do that? I want to find out number of atoms inside a copper first. So how will I do that? We know molar mass is 63.55. So we can find out the number of moles. Number of moles is going to be gram mass upon molar mass, right? Gram mass is 10 divided by molar mass, 63.55 gram per mole. So why I am finding out number of moles? Because if I find out the number of moles and if I multiply it with the Avogadro's number, then I will get the total amount of electrons in copper. So total amount of atoms in copper, and as a result I will get total amount of electrons which were removed from the copper, right? Okay, so let's do this. 10 gram, so this G will get cancelled. This will be 1 upon 6.355 mole. Okay, if we calculate that, it is 0.1574 mole. It is 0.1574 mole. So this many mole of copper consists, this many moles of copper are there in this 10 gram plate. Now I want to find out total number of atoms. So what I have to do? I have to multiply with the Avogadro's number. So number of mole is 0.1574. Multiply with the Avogadro's number 6.022 into 10 to the power 23. Let's do that. So it will be approximately 9.48 into 10 to the power 22 atoms. Okay, this many atoms are there. Now from this atom each electron is removed, right? So how much charge will be there? Q. Each atom will be one positive charge, right? Each atom will acquire plus 1.6 into 10 to the power -19 Coulomb, because that much negative charge is already gone out. So multiply this number of atoms with the electronic charge. So this is N times E. So this is 9.48 into 10 to the power 22 into 1.6 into 10 raised to minus 19 Coulomb, right? So let's do that calculation again. This will approximately come out to be 15,184 Coulomb. Now see, I have already told you that 1 Coulomb is a very large charge, okay? 1 Coulomb is very high charge. And now this is 15,000 Coulomb. So this is very high charge. Now because of this repulsion of this many charge itself, it will explode like anything. Okay, this small copper plate will explode like anything. Okay, and to give you an idea, a lightning thunder will carry about 5 to 15 coulombs of charge. Now if you consider 15 coulomb of charge carried by a lightning, then this is 15,184. That means it is at least 1,000 times greater charge, that too in this small plate. So it is like thousands of thunderbolt energy is in this particular thing. Okay, so if you remove from each atom an electron, it will explode. Okay, let's look at the next question. Okay, let's look at this question. The question is, can a body have a charge of 0.32 into 10 to the power minus 18 Coulomb, 0.64 into 10 to the power minus 20 Coulomb, 4.8 into 10 to the power minus 21 Coulomb? Let's look at this question. Okay, so how will I know if a body can have? What does it mean? See, a body can have this much charge if it follows this relation Q is equal to Ne. And if I put this value here and I know the electronic charge, fundamental charge, which is 1.6 into 10 to the power minus 19. If I divide Q by E, then N must be an integer, because the electrons can only come in 1, 2, 3, that is the integers, right? They cannot come in fractions. So here we will see Q is 0.32 into 10 to the power minus 18 is equal to N is the number into 1.6 into 10 raised to minus 19, right? If I do this, this will become 10. If I divide by 10 to the power minus 19, it will be 10. 0.32 divided by 1.6 is equal to N. So N is equal to 2, right? N is equal to 2. So these 2 electrons will make up a charge of 0.32 into 10 to the power minus 18. Correct? So N is equal to 2. That means this is correct. This can be, a body can have a charge like this. Okay, because 2 electrons you can have. If it was 2.5, it will not be correct. Let's do the second one. A Q is given as 0.64 into 10 raised to minus 20. And this is N. By the way, this is a positive charge, 1.6 into 10 to the power minus 19. It is not an electronic charge, positive charge. But the fundamental unit is same, right? So 0.64 into 10 raised to minus 20. So this will get cancelled. Sorry, this is why I am doing that. It should be 1.6 into 10 raised to minus 19, right? Okay, so this, if it goes there, it will become 10. Okay, now 0.64 divided by 16 is equal to N. So if I know 64 by 16, right? What is that? 4. So N is equal to 4 into 10 raised to minus 2, that is 0.04. So can N be 0.04? You cannot have 0.04 of an electron. So yes, this cannot have, a body cannot have this charge. Now for the third question, you try yourself and tell me the answer in comments. Okay, tell me the value of N that you get and tell me if the body can have a charge of this. Thank you.